Welcome to Setting Course, an ABS podcast where we're charting the future of the marine and offshore industries. I'm Brad Cox, and I'll be your host today. When we talk about the decarbonization of shipping, it's usually the fuels that make the headlines. But beyond the engine, there's a broad range of new technologies changing how we think about ship design and operations. Among those technologies is a design for a ship that doesn't have a stern tube. In fact, it uses a propeller shaft bearing arrangement that's lubricated by seawater. The design was jointly developed by the Blue Ocean Alliance, which includes the Shanghai Merchant Ship Design and Research Institute, better known as SIDARI, Thordon Bearings, Wärtsilä Shaftline Solutions, the National Technical University of Athens, and ABS. Craig Carter, Vice President of Business Development of Thordon Bearings, has joined us today to discuss the design and its impacts on the industry. Thanks for joining us today, Craig.
Thank you. I'm really happy to be here, Brad.
And also with us to discuss the design is Chris Leontopoulos, ABS Vice President of Technology. Thanks for being here, Chris.
Thank you, Brad. Thanks for inviting.
I'd like to jump right in here. Like I said, we often talk about the fuels and energy efficiency technologies, but this Sterntubeless design fits into the decarbonization discussion a little bit differently. Why should this design matter to the industry, Craig?
If you look at the way shipping has grown over the past 5, 10, 15 years, there's been a lot of focus on kind of what goes up the smokestack, looking at carbon dioxide, sulfur dioxide, that type of thing. And there's not been a lot of focus on what's happening below the waterline in shipping. So what we try to do is come up with something that can eliminate a source of pollution below the waterline. And currently, most of the ships today use an oil lubricated propeller shaft bearing system. And with that system, there is a risk of oil pollution if a seal gets damaged, whether that be an accidental seal damage where a rope or a fishing net gets wrapped around the propeller shaft and damages the seal, allowing oil to leak out into the oceans or seas, or it could actually have water ingress into the stern tube, which is actually very catastrophic for shipping as well. And then the other thing with the use of oil lubricated propeller shafts is over time, sealing lips can wear. And that allows like a small discharge of oil, maybe 4, 6, 8 liters a day from the ship's propeller shaft system. So what we're trying to do is eliminate that source of pollution. And seawater lubricated bearings have been used historically over the last 25, 30 years. There's probably about 700 or 800 merchant ships, but the majority are still using oil because the perception is from the ship owner is that seawater lubrication is a higher cost than an oil lubricated system, as well as there's some concerns about some corrosion risks due to the propeller shaft operating now in a saltwater environment. So that's something we can discuss a little bit further as we get into this podcast.
And Chris, what do you see as far as why this is going to have such an impact on the industry?
Well, first of all, sometimes we do not question arrangements. Design arrangements have been there for years, and we just think that it has always been like that. However, first of all and foremost, seawater is free. It's free of charge, unlike oil, particularly environmentally accepted lubricants, which are obviously biodegradable oils, and they are far more expensive. So the question is, if the technology exists and if there are materials that can make bearings that can operate reliably using seawater as a lubricant, why not use seawater, which is plenty and has zero carbon footprint? So that's where we started from. And then, of course, we have been hearing all these stories from superintendents and technical directors from shipping companies, where basically they have their vessel towed by the tugboat because of the bearing failure, because the oil fin collapsed and the shafts touched the surface of the bearing and wiped it out, and we had huge temperatures, and therefore the ship is not operational anymore, and the tugboat will take the ship back to the shipyard. And that's a huge cost, and above all is a huge headache to the shipping company, the operator, out of charter, costs, time, and the rectification. So Blue Ocean Alliance, we started from trying to address these kind of problems. And given that naval vessels like frigates, submarines use indeed water lubricated bearings, albeit with a stern tube, we started from there to see that there is a technology that works. And why not use this technology in commercial vessels? And yes, without a stern tube, because the stern tube is not needed when you have water lubricated bearings, because traditionally the stern tube has been an oil bath But now there is no oil, so there's no need for a stern tube. And therefore, why can't a stern tube occupy this space in the vessel, making the access of the bearings not possible? So the bearings, the tail shaft bearings, in current traditional vessels, they are not accessible by human inspector. So to access these bearings, you have to remove the tail shaft, you have to withdraw the tail shaft, disassemble it, you have to remove the propeller, you have to withdraw the tail shaft, and then intermediate shaft, remove the coupling board. So it's a whole process, which actually, even the process itself can introduce risks of failure, so-called maintenance-induced failure. So all these headaches, we wanted to eliminate them from the operators, and with the proposed arrangement, so-called Sterntubeless Vessels with water lubricated bearings, addresses all these issues. It addresses the risk of pollution, it addresses the accessibility, inspection, and operation.
So I think you guys kind of really teed up this next question pretty well, and maybe even answered it a little bit. But they say necessity is the mother of all inventions. So how did this design come about? Was there a known need that this needed to be solved, or had nobody really questioned this situation before?
It's kind of interesting because if you think about, the propeller shaft lines of merchant fleet vessels, we've been using basically the same design for 70 years. I mean, it's a sealed system. It's using mineral oil. When the United States Environmental Protection Agency came up with the VGP, they kind of forced owners to actually look at this. They had to either improve their sealing system or use a biodegradable lubricant. So that kind of was the first time when ship owners started paying attention to an oil lubricated stern tube system. And when we're looking at options, air seals, which are commonly used now, and ships are still converting to air seals today, they are an expensive and complicated solution, but it meets all the regulations for the U.S. Vessel General Permit. Looking at other alternatives, such as water lubricated bearings, which the U.S. EPA recommends in their Vessel General Permit, it's actually stated that new build ship owners should consider water lubricated bearings because then there's a zero pollution risk. And I think mainstream shipping, when they look at water lubricated bearings, they have this perception that this is old technology. And I think they don't realize that there are new polymer bearing materials. There's ways now to control the maintenance cycles. We have water lubricated bearings on some ships that have lasted 25 years now. So it's a matter of educating the ship owners, as well as working with the naval architects and the shipyards as well, to try and change that perception that this is old technology, because it's actually new technology. This could change propulsion systems of vessels in the future if this technology is adopted.
Right. And, like you mentioned, this water lubrication isn't necessarily new in general, but with the Thordon's T-Boss system, how exactly does that work? What's the difference versus older, water lubricating systems? And really, what are the benefits and maybe is there space savings on board? What kind of makes this stand out?
Chris and I have talked about this many times. The risk reduction of using a water lubricated system without a stern tube and one bearing is that you never have to withdraw the tail shaft nor remove the propeller for maintenance. You can maintain the bearings and the seals. You can inspect it. Class surveyors can come on board, and you don't have to dry it off the vessel. You can inspect the liners. You can inspect the seals. So that's a huge, risk reduction for a ship owner, because typically they don't have to do that with an oil system. Sometimes they do, but so what it does, it makes the stern tubeless design very technically equivalent to an oil lubricated system, eliminating those risks of pollution. And, when we look at shipbuilding costs, CapEx as well as OpEx, the CapEx is about the same as an oil lubricated system, but the OpEx is really, really lower with a water lubricated system, and just removes the risk for the ship owner.
So once the design phase kind of started and you kind of understood what was needed, the Blue Ocean Alliance formed, what were the biggest challenges, in getting this design together, either technically or what have you, to getting it to a place where it could go on board a ship?
Sure, yes. It all started with a brainstorming session between ABS and Thordon Bearings 3-4 years ago. The joint development group started by trying to create so-called the dream propulsion shaft line. It would be a simple propulsion line which can be reviewed and checked, and the calculations for it that accompany obviously the design of a propulsion system is simple, verifiable, and of course, it's operationally attractive. In addition to the pollution risk, which is in this case zero. This Blue Ocean Alliance, it was committed to go and design something which is convenient for the climate approval engineer to review because it has so few parts. It doesn't have a stand tube. It doesn't have the piping system that comes with a cooling water jacket around the stand tube. So it's about simplicity, and simplicity is also about safety. And then over time, we decided that we should redesign in a simple, again, way the aft part of the vessel by creating the so-called aft inspection chamber. It's a space which, because of the absence of a stand tube, it can be utilized by a human inspector. So behind the aft bulkhead of the engine room, a human inspector can enter this space, inspect the shaft, inspect the seal, the aft seal, and perform work in there, such as bearing replacement. I don't want to go into too many technical details, but just to highlight the fact that you can replace the bearing on board without having to go to the dry dock. And that's a very big benefit to the vessel and the operator. And it is not specific to a specific ship type. So, for example, the arrangement can be used in LNG vessels, container vessels, bulk carriers, oil tankers, chemical tankers, or whatever. So the only challenge here is that the space, this aft stand tube chamber, is big enough for a human inspector to enter. So if it's a very, very small vessel, that space will be so small that the human inspector will not be able to enter. And that's the only challenge in the design. I would say it's ship type agnostic, so it doesn't matter which ship type it is used, because all the commercial vessels, most of them, they use single or twin screw. They use a slow slip engine, or even a high-speed engine at intermediate shaft and propeller. So it's only the size of the vessel. So if it's too small and the human inspector cannot enter the area, then these benefits of the onboard replacement of the bearing are not materialized. But any mid-sized vessel, again, whether it's tanker, container, LNG, or bulk carrier, will benefit from such an arrangement. And I sincerely hope that in the future, all vessels are big like that. One more point that you like to make in terms of from the classification point of view. We have tested this arrangement against the existing rules of ABS. And the shaft alignment rules are not common amongst the plug societies, but they are similar, very similar. We did not need to devise a new rule for this arrangement to approve it. Even the existing rules are such that they allow the approval of such an arrangement. The thing that ABS did is they put these rules together in a guide, which we published last June, so that it's convenient for the shipyards and the designers to have all the rules together in order to get to design the arrangement and for ABS to approve it.
And Craig, from Thordon's perspective, what were the big challenges that had to be overcome, in developing the design?
Well, we were happy to work with ABS, of course. As Chris said, this process started, I think, in 2018. When we got Sederi, the Chinese design house, involved, they actually took a container ship, an existing container ship with an oil lubricated stern tube, and actually made the modifications to the design. When that happened, we kind of saw it come to fruition that, hey, this can work. And then with ABS and NTUA looking at everything, how this will impact the alignment of the vessel, the weights, everything related to the propulsion to ensure that, it's not going to impact the ship. And the research that was done said, as Chris just said, any type of ship, it doesn't matter what kind of engine is being used, it will work. Getting past that really helped us. Then the other thing is trying to educate shipyards and naval architects around the world, because this is a fairly big change to the aft end of the ship. So that has been a process that both Dr. Leontopoulos and Thordon and Sederi are working with shipyards and naval architects around the world to increase the education and understand, because one of the things that we found in visiting some of the shipyards is many of them aren't even familiar with water lubricated shaft lines. So there's first that obstacle to overcome, to explain how a polymer bearing and a water lubricated shaft line. And then there's the elimination of the stern tube, elimination of the aft seal, because it's an open system. The water comes in, lubricates the bearing, takes away the heat, and then flows back out into the ocean. And that's very foreign to many shipyards around the world. So that is a big obstacle. But we are seeing shipyards and naval architects now, today, in the last few months, really recognize that, hey, this looks good. And I'm just saying that because of some of the feedback we've had. And we had some really good discussions with some of the yards and naval architects around the world.
So, circling back to the pollution discussion, I think this stuff's really interesting. When you look at it, like I said, we talk about the emissions, that's going to be the big topic, but, this stuff still matters as well. So where does this fit into the regulatory side of things?
ABS and class societies have rules regarding water lubricated bearings. So water lubricated bearings may not be the main trend for commercial vessels, but there are certainly commercial vessels that do have water lubricated bearings, which have actually lasted very long and they have been very reliable. Of course, naval vessels, they use them as kind of more standard in their designs. So it is not anything particularly new here. So there is no special regulation that would prevent or either encourage, other than the existing, obviously, environment that we need to have reduced carbon footprint. And by not using oil throughout the lifetime of the vessel, you reduce your carbon footprint. That's important, let alone the CapEx and the OpEx benefits that we did mention. And the classic question that some technical people ask is, what about if the seawater is not clean enough, or if there is like dirt or the mud or other things? And again, it is very important to say that while this is an open loop system, so that means that the water comes from the sea, then it goes through a water quality unit, so a conditioning unit, as we call it. It's got a filter, and it can filter the seawater to very fine filtering stages. So the water that goes into the bearing as a lubricant now is filtered. So there's no way that can cause excessive friction or problems, because it's filtered seawater. In the design, we have two water quality packages on board the ship, one which wets all the time and one which is on standby for redundancy purposes.
Is there regulation specific to that sort of pollution, or is this a reportable, we're using less oil? Something you can tell the IMO or the EU, is this a reportable thing that could have benefits in the regulatory environment?
It doesn't come to the equation of EEDI or EXI or CIRA, but oil leakage, particularly in the Americas seawaters, is an illegal offense, whether this is mineral oil or whether it is environmentally accepted lubricant. Then the US Coast Guard can put huge fines to vessels whose seals leak oil into American waters. And of course, that's a violation in many other parts of the world, including Europe. From that point of view, yes, of course, you should not pollute with oil the seas. But this kind of water lubrication, no use of oil as a lubricant, has not creeped into the equations of EEDI, yet science, not yet in that.
If I can just add to that, the most stringent regulations when it comes to any oil discharges are vessels that trade in U.S. waters. So the U.S. Vessel General Permit has a rule that basically has an oil to sea interface, and that is where the lubricating oil and the ocean where they could meet. So they have said that if you're trading in U.S. waters, you must use a biodegradable lubricant, or you must, eliminate that oil to sea interface. So there's basically two ways that today's ship owners have changed their stern tube, oil lubricated stern tube environment. And that is either switching to biodegradable lubricants or improve their sealing so there's no oil to sea interface. And most of the ship owners that trade with the U.S. have upgraded their sealing system to what's called an ear seal. So there's a gap in there that removes that oil to sea interface, and that allows them to meet the regulations for the vessel trading in U.S. waters. So by going with water, you eliminate both of those issues. You don't have to worry about buying biodegradable lubricants, which are typically 10 times more expensive than the oils that are used. Or you go with the complex ear seal, which is also quite expensive, and you have to maintain it, and you have to check the sealing lips and ensure that they are working properly. And the other thing is they are never foolproof, because ships operate all over the world and there's fishing lines and nets and things happen. in the oceans and seas, as everybody knows. So it just eliminates that risk and meets all the pollution laws around the world. But the US EPA vessel general permit is probably the most stringent that's in force today.
So, I'm kind of going back to the technology itself. Where does that technology stand today? And, what's the long-term potential here?
So we do not have any ships using this Sterntubeless design today. However, the interest that we've seen all around the world from ship owners and shipyards has been very, very high. We have already received quotation requests from some of the biggest shipbuilding yards in South Korea as well as in China. And we have owner interest from Europe and USA and Canada. So the interest is high. We don't have it yet, but I believe that shipping is a very conservative industry, and change, it takes some time. But I believe that when the first owner decides to have a ship built with this Sterntubeless design and looks at the CapEx and the OpEx, everyone that we've presented to from the ship owner community has said, this is a no-brainer. So that's the kind of feedback that I've received. And Chris, maybe you can add to that.
Yes, I fully agree with that. And as I said earlier, although the ABS is a classification of society and it is acting as independent body, this is basically a no-brainer. And I think that this design, it's easy to maintain. It is cheaper to operate, and it's easy from the plan approval point of view. So it's simple. Simplicity is the word, not in addition to zero pollution risk.
Yeah, the other thing that was interesting when we talked to ship owners is if you look at an existing ship design today and change it to a Sterntubeless design, and Chris touched on this a little bit with regards to the propeller shaft actually could be shorter. And if they shorten the propeller shaft, the engine could move aft, meaning there's extra cargo carrying capacity. So some shipyards that we talked to have said they've already made some changes, so they can't really change where the engine is located. But in other yards, they say this looks like a possibility. So depending on the shipyard, the design of the vessel, that type of thing, you could actually take an existing ship with a stern tube and oil lubricated, change that design and get more cargo capacity with the same size of ship. So that's where we talked a little bit about like the improved EEDI, where you're now carrying more capacity with the same ship. And to me, that's also like a big benefit, but that also depends on the ship's designers and how they make those changes to the ship.
Yeah, absolutely right. Totally agree with that. Definitely for the same length of ship with what we are proposing with the shaft line, okay, and they're considering the bearing loads, the bearing position of the shaft alignment, calculations. So you can have a shorter shaft, which is fully compliant with the rules and simple, safe, reliable, more reliable than the traditional shaft lines. And at the same time, the shorter shaft line means smaller engine room space, which for the same length of vessel is more cargo space. So more cargo space, less engine room space is a very good thing for the EEDI. It's a very good thing. It makes sense anyway, because we don't want to carry engines, we want to carry load and cargo. So minimizing the engine room space within reason is a good thing anyway. And that design arrangement is very capable of doing that, and it's actually designed to be.
It's maritime economics 101. More cargo is usually a good thing. So to wrap things up here, I wondered if each of you had any closing thoughts on the topic or the state of the industry that you wanted to leave our listeners with. Craig, why don't you go first?
So we've talked about some of the benefits, and that, of course, the pollution is the big one. But I think many ship owners are looking at the CapEx and OpEx of making a change to their design. And to me, that's probably the biggest thing. You're looking at something that reduces the risk from pollution, from operation. You're lowering the operating costs of that vessel. And it's not like this is something brand new. It is new for a lot of ship owners because they haven't seen a lot of vessels with water lubricated bearings. But we have over 700 merchant vessels operating in shafts up to 920 millimeters for container ships and tankers. The technology is there. It's an improvement on existing designs and materials. And the other thing is, like, ship owners, if they're interested in this, I know ABS has produced a guide, the requirements for Sterntubeless vessels, and there's a lot of really good detailed information in that guide. So if anyone needs that, it's available on the ABS website, but it's a great guide for people to learn more about this technology.
And Chris?
I would like to say that this is a new, but not exactly very new proposal. So two categories. The majority of commercial merchant ships, it would be new because they use oil lubricated bearings and traditional shaft lines with Sterntubeless. But there is a smaller category of commercial merchant vessels that use water lubricated bearings quite successfully, albeit with the Sterntubeless. So for these kinds of vessels, it's not a very big leap forward. The only other benefit that if they were to follow the Sterntubeless design is simply to remove the Sterntube because it's useless. So if they did that, then they basically would comply with this proposed arrangement, so-called Sterntubeless vessels, with all the benefits that we did mention. And I wanted to add that the concept, this arrangement, has received the Lloyd's List Technical Achievement Award 2022.
Okay, great. Well, once again, thank you, gentlemen, for joining us for the show. This whole Sterntubeless design, really interested to see it, in practice and start seeing it on ships. So Craig, Chris, thanks again for joining us today.
Thank you, Brett. Appreciate the time.
Thank you, Brad.
And for the listeners, thank you for joining us for another episode of Setting Course. Be sure to leave a review, give us a follow, and share the episode. To learn more about new maritime technologies, visit us at www.eagle.org. Thank you for listening.